section 4.3, triangle sum theorems. There are two very useful theorems for triangles that we can use to help solve the measures of the angles in a triangle. And the first one here, so we want to be able to use the triangle sum theorem. So we have an interior theorem and we have an exterior angle theorem to solve problems about triangles. And so the triangle sum theorem is the sum of the measures of the angles of a triangle is 180 degrees. And we can think about that a couple of ways. So first of all, I just mentioned that every equilateral triangle is also equiangular. And if you were paying attention yesterday, all those angles on the homework worksheet, they were 60, 60, 60. And what is 60 plus 60 plus 60? 180 degrees. But that's not the best way to think about it. Oh, shoot. I'm unprepared for today's lesson. Let me see if I have it from last year. Bummer. I have this, like, thing. Well, I'll have to show you something. I'll have to show you something after. I'll make a little something, which is kind of cool to show why the angles of a triangle equal 180, but that's okay. I'll get to it later. But that's pretty easy, just to know that an equilateral, equiangular triangle is 60, 60, 60, and then just thinking you can add those up, it's going to equal 180. And it doesn't matter how we slide or rearrange a vertex of a triangle, that they're always going to add to be 180 degrees. It's just something you can count on. So we also have the exterior angle theorem. An exterior angle is formed by extending any one side of the triangle. And so it turns out that an exterior angle, so this would be like angle number 1, we would call an exterior angle. Why would we call angle 1 an exterior angle? Because it's on the outside, it's not on the interior. So the exterior angle is equal to the sum. What does sum mean? The total, yeah, adding up two things together of the two non-adjacent interior angles. Non-adjacent. If I put a 4 here, 4 would be adjacent to angle 1. It's right next door to it, yeah? Okay. So we want the non-adjacent, and that would be angle 2 and angle 3. So the ones far away. So the measure of angle 2 plus the measure of angle 3 turns out to equal the measure of angle 1. Which we can actually prove, well, really easily here. Let's just make up some numbers here. If I know that the measures of all three angles should add to be 180 degrees. So let's say that this angle 2 is 40 degrees, and let's say that this is 60 degrees. Angle 3 is 60. All right, 40 plus 60 is 100. What's the measure of angle 4? 80. How'd you get 80?
Because equals 180.
Yeah, because 40 plus 60 plus 80 should equal 180. We just said that all the interior angles equal 180. All right, if angle 4 is 80 degrees, what's angle 1? 100. How do we know it's 100? Yeah, because it's a straight line formed right here, yeah? Yeah, they're a linear pair. Very good word usage. So 80 plus 100 is 180 because it forms a linear pair. And then we can see that there's the 100, and it turns out that that's 40 plus 60. Hey! All right, so that exterior angle does, in fact, add up to be the sum of the non-adjacent angles there. Okay, perfect. So we have these two theorems that we're using today. Pretty easy here. We want to find all the missing angles labeled here. So how do we figure out the measure of angle 1? subtract that from 180. So 180 minus 24 minus 37. Yeah, absolutely. I don't have a calculator. 119. Thank you, guys. All right. So from 180, because we know all three angles need to add to be 180, we can just take 180 and subtract each angle. Let's see. This, angle 1, what kind of angle is angle 1? Exterior angle, which means the measure of angle 1 is going to equal the sum of 76 plus 52, the sum of the non-adjacent. 128, all right. Angle 3, I have, what kind of angle is this, 104? Exterior angle, all right. And I know that my exterior angle equals the sum of the two non-adjacent interior angles. So the 104 should equal 79 plus the measure of angle 1. So how do we figure out the measure of angle 1? Yeah, subtract 79. So 104 minus 79, and we get 25. So many ways to do it.
I did a random way and got one then calculated.
Oh, okay.
It was one off.
One off.
Yeah, I got 103. Then I did 25.
Huh. Oh, okay. Lots of ways to do these, so that's really pretty interesting. Let's look at in number 4 here. We have to figure out the measure of angle 1, the measure of angle 2, and the measure of angle 3. Where do you want to start?
Measure 1.
And subtract from 180, sure. So we can figure out the measure of angle 1 pretty easily. So the measure of angle 1, I'm going to draw an arrow right there. So 1, we know we've got a little triangle here, so we know that all three angles should be 180, and so we can subtract the 66 and subtract the 84. 30, yeah. All right, so there's the measure of angle 1, so we can just subtract the other two angles. And we can get 3 then. If we know 84, then how do we figure out angle 3?
You minus 84 from 180.
Yeah, again, we have a linear pair here, so 180 minus 84 is going to be 96. Great. And now that we know that this is 96, and you'll notice I wrote it in there because I think that that's helpful. So now we can figure out the measure of angle 2. How are we going to figure out the measure of angle 2? Yeah, subtract the 96 and 43 from 180. So 180 minus 96 minus 43, and that's going to give me 41. Yes, 41 degrees. I love all the colors. It's so fun.
Plug it in. After I do it, I plug it in by doing 96 plus 43 plus 41 to see if it equals out.
That's a great double check, absolutely. So yeah, to go back and say, hey, if I have my angle 2 plus angle 3 plus the 43 should equal 180. Good double check. All right, how are you doing with this? Are you pretty okay with this? Let's look at number 6. I love these, I like to call them triangle puzzles. What can you see right off the bat? It looks like an hourglass. Does kind of look like, or a bow tie. Yeah? All right, what else do we know? You see a 90-degree angle. Very good. We do have a 90-degree angle right there, a little box in the corner, 90 degrees. Good. What else do we know? No, it is not an exterior angle to 61. Right here would be the exterior angle of 61.
Wouldn't angle 2 and angle 3 be 45? Because
not necessarily.
Wouldn't 61 and 2 be vertical?
Yes, that's what I was waiting for. Good. 61 and angle 2 are what kind of angles? Vertical angles are congruent. So that means that the measure of angle 2 is also 61 degrees. They are vertical angles, so we can't forget about that. That's good to know. So angle 2 is also a 61 degree there. All right, can we figure out the measure of angle 1? Yep, how do we do that? Subtract from 180, yes, because the angles in a triangle add to be 180. So 180 minus 61 minus 68 gives me 51. All right, and then
Measure 3, you would do, I just added all of them, so, or I added the 90 and the,
90 plus 61, and then
minus that.
from 180, yeah.
And then I got, 29. That should plug it.
Yep, 29 degrees. Beautiful. All right, great. I like number 7 because, again, it's using vocabulary that you need to read. And, again, the hardest part of math is the reading aspect. BC bisects angle ACD. So segment BC is bisecting angle ACD. If you bisect an angle, what do you create?
Perfect tack.
Two congruent angles, all right? So we're bisecting an angle, so we're going to create two congruent smaller angles. So ACD is right here, and this line is bisecting it. So we have two congruent angle measures. Angle 2 is congruent to angle 3, and it started out as 90 degrees. So what can we conclude?
45.
Oh, that's good. They're both 45 degrees. So 2 and 3 are 45 degrees each. All right, and now that we know that, because we took our information, all right, now we have a 48 and a 45. What's the measure of angle 1?
87.
How'd you get 87?
48 minus 180.
Subtract from 180. Good. So 180 minus 48 minus the 45, and we get 87. Good. And then angle 4, similarly, little triangle here, so we can 180 and minus the other two angles that we already know, which will give me 52. Thank you. Good. Great. Super duper. Oh, I love these. They're so good. I do. I love these. Look at this. We have really good information. Let's look at number 9. Number 9. Oh, we got some parallel lines. Holy moly. We got some parallel lines here. Line L is parallel to line M. So we have lots of little special angles. All right, watch. I draw my parallel line, and then I hit a transversal, and then I go back and I hit my parallel line.
Oh,
You see the Z?
40, number 4 would be 40.
Yeah, so there's that Z shape. All right, when you have that parallel line, transversal, parallel line, Z shape going on, or maybe it's an N, or some weird backwards and flipped in, some sort of Z form or shape. We get alternate interior angles, and they're congruent. So this angle 4 is also 49 degrees. So using those parallel lines can be very, very helpful. Let's look again. We have more parallel lines. We still have the same parallel lines, but here we have parallel line, transversal, and then a parallel line in purple. So now what do you see?
Angle 1 is
Yeah, angle 1 is congruent to angle 70, the 73 degree angle. So that is also 73 degrees. So really important to be able to find those. Anytime you've got parallel lines, you've got congruent angles all over the place. So you really want to be able to hunt for those. That is like priority number 1. Can we figure out the measure of angle 2? Yeah, why?
The angle of measurement 2 would be 58.
Subtract from 180. Yeah, we got a linear triple is what this is called. We have 3 angles all on this straight line L. So again, we can subtract from 180 because they should all add up to be 180. So 180 minus the 73 minus the 49. And what do we get for angle 2? 58. Okay, good.
Oh wait, I did the inside one. I got 50.
Oh, so you did the triangle.
Yeah.
Yeah, multiple ways, right? So that's what's hard about geometry. There's a million ways to get the same answer. But that is the key. It's still going to give you the same thing. So, yes, you saw the triangle and said, oh, hey, same thing here. I've got a triangle, so I know they should add up to be 180. So 180 minus this 73 minus this 4. So, yeah, lots of ways, which is kind of cool, I think. It's really neat. So, all right, 73 and angle 3. $107. How'd you get 107? Yeah, 180 minus the 73 because they are adjacent. They form a linear pair right here. All right, and so number 3 is 107. Same for number 5. What is number 5 going to give you?
131.
180 minus 49 gives you 131. Again, because we have a linear pair. They are adjacent on the straight line, so they add to be 180. Okay. Very cool. All right, that's good. Let's go down to, because this is more of what your homework is going to be here. So, 12 through 15, here we go. Solve for x, then find each angle measure. Today is the Delta Math assignment, and most of the problems look like this, but also they might not give you a picture.
Altman.
Okay? Instead, you're going to have to read and write. All right? Which means if they don't have a picture, can you make a picture? Sure. If they say, in triangle ABC, what should you draw? Triangle, and label it A, B, and C for the vertices, yeah? So triangle, draw the triangle, label the triangle, fill it in. Much like we've done already for you here, fill in the angle measures. Because all 3 angles should add to be what? 180. So 5x minus 2 plus 9x plus 3 plus 11x minus 21 should all add to be 180 degrees. All 3 angles add up to be 180 degrees. So let's see, I've got a bunch of x's. 11 and 9 is 20, plus 5 is 25 x's. And then I have, let's see, a negative 2, a positive 3, and a negative 21. So 20, negative 20? Negative 20, yeah. All right, equals 180. And then we can solve for x. So what should we do first? Add the 20. So we get 25x equals 200. 8. X equals 8. Very good. And then, so that is solving for x. And again, in Delta Math, you got to read carefully. Do they want you to solve for x, or do they want to measure the angle? So what do we have to do? Plug them back in. So we're going to take go back to our angle measures here and plug in the 8. So we have 5 times 8 minus 2, which gives me 38 degrees for measure of angle D. For E, I'm going to go back and again plug in my x value. So 9 times 8 plus 3, 75 degrees. Good. And then 11 times 8 minus 21? 67. All right. I'm so glad you guys don't do that all the time. All right. Questions on that one? Is that good? Do we need to do number 13?
No.
All right. What? No. We're not done with it. We got.
We're at like 18 minutes.
Okay. Well, one more. 14 or 15?
15. Yeah, 15. 15.
Okay. So here on 15, what kind of angle is this angle right here? Exterior angle. So this is going to use the exterior angle theorem, which says what?
The non-adjacent side.
The non-adjacent angles add up to be the exterior angle. Good. So, so 5x minus 27 plus 7x minus 32 equals 9x minus 8. So not 180. So be careful, okay? The exterior angle is the sum of the two non-adjacent interior angles. And then we can go ahead and clean that up. 5x's plus 7x's is 12x's. Negative 27 and negative 32 is negative 59 equals the 9x minus 8. And then I'm going to go ahead and move the 9 over. So subtract 9. And then I'm going to go ahead and add 59 to both sides. And if I add 59, that gives me 51. And then I divide by 3. 3 goes into 5 one time with 2 left over, and that would be 3 goes into 21, which is 7 times. All right, so x is 17, and then what do we have to do?
Plug it in.
Plug it in, plug it in. Okay, so I have to read carefully. We want the measure of angle JKL. JKL, that's this one right here. So 7 times 17 minus 32. The x is 17.
87.
87. All right, and then KJL, that's this angle here. So 5 times 17 minus the 27.
58.
Okay, 58. Then it wants KLJ. Ooh, that's this angle right here.
Oh wait, I got it. Hold on.
Okay, yeah, we could do that. It's the interior angle.
35.
So 180 minus these two, so minus the 87 and minus the 58, does give me 35. And then the last one, KLM, that is our exterior angle. And we can do it a couple of different ways, but I'm just going to go ahead and plug in 9 times 17 minus 8. Why am I going to just plug it in directly instead of, I could just subtract 35 from 180. So, if I subtracted wrong, then the green thing is wrong. Like if I mishit something, right? And then if I use that wrong thing to calculate the pink thing, then that is also wrong, right? So by going directly to what I know is correct, I'm lessening the chances for making a mistake twice. Like, does that make sense? But anyway, it does work out, you know? So that's what I'm thinking. If I accidentally, like, mishit a button on a calculator, and I did 180 minus 88 minus 58, then the green one is wrong. And then I use the green one to get the pink angle, then that is also wrong. So that's compounding wrong errors. All right, so anyway, so there we go. Do you have questions for me?
No.
All right, we got two theorems. Add them up and they equal 180, or the exterior angle theorem that you're using today.